Hey y'all, Rusty Rob here. Welcome to another video. Today we're going to try to do this LeetCode problem of the day, which is to invert a binary tree. And I heard that is it the guy that created Homebrew? He had an interview with Google, and they asked him to invert a binary tree, and he didn't know what that meant. And I don't think he got the job, but which is quite funny because he's obviously a very good programmer since he created Homebrew. But yeah, take these kinds of things with a bit of a grain of sand. I think I've inverted a binary tree before. I can't really remember. I think because I've done a few tree algorithms before, it should be reasonably straightforward. But with Rust, it might be quite difficult. So let's have a look, and I'll just show you why. So first, I found this thread where it says, please use an optional box of tree node instead of RC ref cell tree node. And because with the tree, it's each node clearly is owned by its parent. The parent has the left and the right children, so we don't really need ref counting and things like that. So it's not really the best way to use a tree. And I'm not that familiar with smart pointers myself, especially since I haven't been doing as much Rust lately, just because I've got a newborn child and been pretty busy with TypeScript at work. But I'm hoping to get back into Rust, so let's jump into this video. Okay. But yeah, basically, I don't know, pause and think about the algorithm, but I'll tell you, we will basically just invert the left subtree and the right subtree, and then we will swap the left and right nodes. And that's just a recursive algorithm. So the left subtree will be inverted, the right subtree will be inverted, and then swap the left and right, and yeah, we should be done. And I'll do this in my editor. So you can see here in the example, like 2 and 7 have swapped, and then 1 has gone to the far right, and so on. 6 has swapped with the 3. Okay, I'll check it in my editor because it'll make it more clear what the types are. So let's go to preview mode, presentation mode. Okay, we'll comment this out. And it doesn't know what solution is, so extract solution. And I think we might need a main method, not sure. What's it complaining about now? This isn't returning anything. Okay, so we just want to return the root. And so I want to go if sum node equals root. Oops. But now we're kind of taking this root, and here we're taking ownership, so we maybe can't return it here. So if we just go as ref, what am I doing wrong here? Expected bool. Oh, we need let. Okay. Cool. So now we've got a node, which is just a reference to this ref counted ref cell. So we've got double smart pointers here, I guess. So if we go let mutable node equal node dot borrow mute, and we're about to mutate this thing. And we said we would first invert the left side. So we'll invert dot left. And then I think we need to clone, because I think this ref mute reference is only valid within the scope. Once it leaves the scope, I think you can't use it. We'll invert the right. I also kind of know to clone because it's like we've got an RC, so we probably have to use clone somewhere. But yeah, that's not a good way to code that kind of logic. All right, now we need to just swap the left and right, and we're done. So if we go to let's see. So we can go like this. We can go let temp. We can use a temp variable equal dot left dot take, and that'll just replace the left side this with the default value, and then we can assign the right side to left, and then we can assign the temp value to right. But I want to use the swap method, not collection, standard mem swap. So swap, what do we want to swap? Node dot left. And cannot mute node is mutable more than once at a time. So I think if we just use a variable, and now cannot borrow star x is mutable more than once at a time. And the problem is here, this is a mutable reference to the ref mute. So if we put a star here, now this is like dereferencing. This is, I think, deref mute, which means we get our smart pointer basically gives us a mutable reference to the tree node. And now we can call swap. And it's not worried that these two, yeah. So Rust is smart enough to know I can swap these two things. Because, yeah, we're mutating X here and here, so we're kind of mutating it twice and one at once, but I guess that's okay. So let's try to run that. And yeah, you could imagine how hard this would be to code in a job interview if you don't have autocomplete or a text editor, an IDE, if they make you code in Notepad or Microsoft Word or something. So let's try to submit that. Cool. And because I had a feeling we would deal with this ref mute thing, I looked it up earlier. So what was this thing here? How does this work? Well, you can see our root is an optional ref counted ref cell to a tree node. So if we get access to the node, and then this borrow mute method, if we go back, if we look up ref cell borrow mute, I think this is what's getting called. Mutably borrows the wrapper value. And ref cells, they kind of allow interior mutability. So I guess it's running in a single thread. So nothing else can really edit it at the same time. Whereas if you had multiple threads, you'd need like a mutex or something like that. So let's have a look at ref mute, because that's what we've got here. And yeah, it implements deref and deref mute. So these are kind of like smart pointers. So here we could have actually just gone like this. And it's the same thing. It's just syntactical sugar, I guess. And the same thing here. And let's try to look at the source for this. So here it's implementing deref and deref mute. And the target is just itself. So here's T, and it's just, I guess, returning a reference to itself, a ref mute of itself. I guess you could have a different target, which would be kind of cool. And let's have a look at the deref trait. So used to mutate dereferencing operations like *v equals 1, or you go like plus equals 1, I guess. That would be an assign. This mechanism is known as deref coercion. So look at the source. Here's a trait. So to implement this trait, you have to already be implementing deref, which is up here. So you have to implement this too. And that's how it knows the target, I guess. So you need to have a method called deref, which takes mutable self and returns a mutable reference to self.target. So if we look back at the source, so it's returning self.value.asMute. And that is unsafe. But we hold our borrow. So it is safe. Okay. Oh well, cool. Thanks for watching the video. And good luck if you're trying to do any tree or linked list problems with Rust on leetcode. But yeah, thanks for watching. And yeah, feel free to like and subscribe.